What's up, guys? Today is day 3 of doing every single lesson for you guys to prepare for the AP Calc, AP or BC. Today we're doing limits at infinity. Not going to go so fast because I know it's a new concept. Something here is kind of new, kind of reviewed depending on your level. But question number 7 MCQ. So looking at here, sine of x is a oscillation function, and the x here is just the amplitude. And although the amplitude is going to infinity, the function as x approaches infinity will not be infinity because it'll just be oscillating. Therefore, the answer does not exist. So also don't write equals to DNE because your teacher is going to mark you wrong for it, because if it does not exist, there's nothing for you to equal it to. Number 2, this is a really interesting one. For me, I looked at it wrong. So when I see something like limit, I just look at whether they're this term, their biggest term, and the biggest term here, and then I just did -2 over -12 is 1 over 6, and obviously this is not 1 over 6. And if you're taking BC, AP Calc BC at my school, your teacher will require you to write out all the steps, because you will make a mistake, and it's very annoying. But basically what you're doing here is multiplying the top and bottom with this right here until you get to -2 times 3, because the 9 goes out there to be a 3, and then the x5, so it'll be like this, right? The x5 cancels out with this. That's why you're doing this to both the top and the bottom, and then this also cancels out with this. And because you're doing the same thing for the top and the bottom, it is fine. Okay, so top is -6, and then the bottom is -12, right? Because we're taking the coefficients of the largest term. There's supposed to be a name. I don't remember the name of the largest term, but you'll see here, this is 6 over 12, so 1 over half, 1 over 2. However, this is only true if this is going to positive infinity. When it's going to negative infinity, everything flips, aka the sign also flips. So it becomes -1/2, option E. Okay, number 9. So for these, remember, look at the term with the biggest coefficient, biggest what's it called, exponent. And here, you have 2 not equal the same exponents. Top is greater than bottom, which means that you have an oblique asymptote. I don't like those. I hate those a lot. So what you have to do, you have to long division, or you can synthetic division, but I'm not going to do that. So let's do that quickly. Oh, I hate long division. But it's fun, like, if it's not that long, but name is long division. Okay, let me hold this. And do this with me if you have paper, see who goes faster. Okay, I'll just put that there. Okay, so to get there, you need x. Yeah, you need x here. No, not here. Here. Ooh, here. Right, and then this would be x4 plus x3 plus 2x2 minus 5. Ooh. Minus that, 5, -1 is -6, x4. Oh shoot, that's supposed to be a 5. Oh yeah, sorry. I haven't brushed up my long division in a long time. 5x4. Okay, so that negative, oh my goodness me, is 0, and then you have, oh, this is annoying. You have, so I'm just going to do it a quick way. So it's, why is this eraser so big? Minus 10x. Why is it 10? Where did I get 10 from? What the heck? 5. Oh my goodness gracious. 5x2 plus 2x. So this would be 7x squared. not squared, cubed. And then we would need, and that's it. So after that, you get your oblique asymptote or slant asymptote as negative 5x plus some remainder. So we know that negative 5x is something like this. So as limit of x approaches negative infinity, or somewhere here, it will go up. So b. Okay? Alright, so next one, it's pretty easy. Same exponent, so it's negative 1 over 1, which is just donkey. Let me double check. I can be wrong at times. Yep, that's right. And then 11, again, another long division. Okay, let's quickly do that. Right, long divisions, you can't escape that from algebra 2 or pre-calc because it's very important. And also plus the zeros, very important. I've actually never got it wrong because I didn't forget my zeros. Our teacher taught us really well here. This is 1 over 4x. Yes, so 1 over 4x is 5x. 3 plus 10 over 4x2, blah blah blah. That would be 0. And then x, that would be negative x of 10 over 4x squared. To get that, you would need 20x or 20y to equal to negative 10 over 4, which means 80 is equal to y is equal to negative 10, y is equal to negative 1 over 8, so it's minus 1 over 8, something like that. So we know that, we have to know that the general shape is, again, it's positive slope with a negative y-intercept. So if it goes to negative, it'll go negative, so it's option A. Yeah, that's correct. Just double check. Okay, number 12. Bottom is greater and it's approaching to an infinity. So basically this, again, if you're taking it in my school, you have to do this, which is very annoying, but it prepares you well. And this basically becomes 0, right? Or x in the bottom, but the mid approaches it becomes 0. This becomes 1, so if you know L'Hopital's, then same thing, but this basically goes to 0. Because like same with 1 over x, right? 1 over x. If it's negative, 0. If it's positive, infinity, it's still 0. So this limit is equal to 0, C. Okay, pretty confident for that. 13. Okay, so we have 2 to the negative x over 3x as x approaches infinity. So I think it's just drawing the graph, right? So if you draw, oh my goodness me. If we draw the graph, this is like this, something like that, right? It's just increasing. That is like similar to e to the negative x, which is also something like that. So if it's basically that, then I would say, based on looking at the shape of the thing, I could be wrong, is something like that. And yes, although this is bigger than this, of course, it just makes it more and more flat. But eventually, when it goes to infinity, it will also go to infinity. So, that is my logic for the first part. However, wait, is e to the x? No, sorry. Wait, my bad. This is this. However, e to the x is this way. My bad. E to the x is this way. So we have two different signs, two different ways. One way to the left, one way to the right. So we can't estimate from that. So we need to separate it. So 2 to the negative x is just 2 over or 1 over 2 to the x, and then as it goes to infinity, this goes to 0. And then this, too many arrows, is 3x as it goes to infinity, or 1 over 3x as it goes to infinity. This also goes to 0, so it's C0. Okay, so, no battery. Okay, these two are the trickiest ones, even for me, when I did this question. So the difference is positive infinity and negative infinity. That's it. And so the first part here is, again, looking at the graph with this wrong twice in a row. But e to the negative x is what it looks like here. And if it's negative, it should be flipped across the y-axis. No, the x-axis. The x-axis. The y-axis is this thing. So if it's negative, it will be something like that, I think. I'm not quite sure. But what it's saying here is that you have these two things. If it goes to infinity, what would it go? So it might seem a little scary at first, but if you break it down into two parts, so this is 5 plus e to the negative x as x approaches infinity. This, as I said before, the graph looks something like this. So this just becomes 5. Okay, and then this is 1 minus e to the negative x as x approaches infinity. That's nothing but 1. Okay, so this is just 5 over 1 or 5. Let's see. Oh, no, not 5. Sorry. Boy. Yeah, that's right. Okay, and then last one, the difference between this and this is that here you know that both of them go to 0 because they all approach 0 when x is going to infinity. However, when x is going to negative infinity, then what would these graphs look like? So this and this, right? So you have positive infinity and negative infinity. So does it not exist? That's not an option. So what do we do here? Again, we can break it down, or we can look at the shape of the graph, right? So this again is 1 over e to the x, and so when 1 over e to the x equals when x goes to infinity, this goes to positive infinity, right? When it goes to negative infinity, like this, right? I've drawn this graph like so many times. Oh my gosh. Okay, and then here, when it goes negative x, this goes to negative infinity. So when you have things like this, similar to the question here, or not here, this one, right? Same kind of logic is that when you have the same power, then you take the coefficient. And so it's probably the same logic here that I would look at. So this is infinity. So infinity over negative infinity does not exist, but is, in this case, it is negative 1. So the answer here would be E. And yeah, that is it for this video. It's a bit tricky. I've drawn like 5 e to the negative x graphs and somehow still managed to get it wrong. But yeah, thank you guys so much for watching, and I'll see you guys tomorrow with 1.4.